These are the first 6 problems on the study guide for the Algebra Test 6, Quarter 3. And so when we look at the first question, is asking us what are the solutions for the quadratic equation, and it's x squared minus 3x equals 28. Well, they're not giving us a specific method to use, so if ever I have a choice, I'm always going to go with factoring first. And so I'm going to go ahead and move this 28 back to the other side. So go ahead and subtract that 28 from both sides, and when I do that, here's my new equation. X squared minus 3x minus 28 equals 0. And so from there, I'll go ahead and try factoring. And when I factor this, I end up with x and x make the x squared, and the numbers that multiply to make 28, but subtract to make 3 would be 7 and 4. To make a negative 3, though, I need negative 7 and a positive 4. So always check your factoring first. Make sure it matches the original equation. Once you've got the factoring done, you're sure it is correct, then take the two factors and use that zero product property, which says if you take the factors and set them equal to 0, then you find the value of x that makes one of those factors 0. When you multiply a number by 0, you always get 0. And so here we end up adding 7 to both sides, and here we'll subtract the 4. And so we get the two values of x. And so x can either be 7, see 7 minus 7 makes 0, which will multiply to equal 0. And over here we have negative 4, which means that negative 4 plus 4 makes 0. 0 times a number makes 0 as well. So those are the two solutions. They're also called zeros. They're also called roots. They're also called x-intercepts. So there it is. And the next one, it's asking us to complete the square. So make sure you read the directions carefully. Complete the square to find the solutions. So when we do that, we're going to take half the b term. And this problem is nice because it's already set up for completing the square. The c term's already on the other side, so I just take half the b term and square that number. That gives me 4. So that's the number I end up having to add to both sides of this equation. So when I do that, I end up with a perfect square trinomial right here that ends up factoring as x plus 2 times x plus 2. So it's a quantity being squared. See, 2 times 2 makes 4, and 2 plus 2 makes 4. And this all equals 3 when I add the negative 1 and the 4 together. So from that point, I can go ahead and take the square root of both sides. That'll cancel out that squared symbol, leaving me just with the binomial x plus 2. But it now equals plus or minus the square root of 3. So I just have that one step of subtracting 2 from all sides, and we'll have our answer. And so we have our x-intercept that we'll leave in the exact form. There's 2 of them because of the plus or minus sign, negative 2, plus or minus the square root of 3. If we wanted to know an approximate, we'd have to approximate the square root of 3, which is somewhere around 1.7. And then we'd have to add that to negative 2, subtract that from negative 2 to give us our 2 x-intercepts. Here they're asking for x-intercepts, and we're supposed to use the quadratic formula this time right here. And so remember, that goes this way. Negative b plus or minus the square root of b squared minus 4ac all over 2a. And so remember, we're setting y equal to 0 because we want to find the x-intercepts. That's what you always do when you find out what the x-intercepts. You always set y equal to 0. There's our a term. Our b term is 4. C term's negative 3. We substitute those numbers in. So we have 4 squared, and then plus or minus. I'm sorry, let's fix that real quick. I was thinking of the discriminant. So negative 4, it's negative b plus or minus the square root of b squared. So 4 squared minus 4ac. So a is 2, c is negative 3, and it's all over 2 times by a, which is 2 in this case. So we do some more work. Underneath the radical sign, we can square the 4, it gets 16. And then plus, notice it's plus because of the negative here and the negative here. And so it's going to be a plus, and then multiply, we end up with 24. If I multiply that 4, the 2, and the 3 all together, and it's all over 4. And so we can go ahead and add those two numbers underneath the radical sign. And so that gives us 40 altogether. Now there is a way to reduce this fraction a little bit to make it a little simpler, but for right now, we're going to leave the answer like this in the exact form. There it is. If we wanted to approximate it, we'd have to approximate the square root of 40. Add that to negative 4, then divide by 4. Subtract it from negative 4, then divide by 4. Well, the next three problems are asking us to simplify. And so what we want to do is always, when we see the constant first, the variable second, take out a -1. So divide each of those terms by -1. And that will switch the signs. And I'm also going to switch the numbers as well. It makes it a positive x and a -9. The reason why I want it that way is that when I factor this, I'm going to end up with positive x. So if I end up having the same factor, I want it to look the same. So I want the x's first, and I want them positive. And so x times x makes x squared. 9 times by 5 makes 45. And if I make it a -9, a positive 5, they'll subtract to make -4. And so you can see now that the x minus 9s will now cancel. But you can only cancel if they're exactly the same signs and all. And so when we go ahead and rewrite what's left over, we got -1 on top and x plus 5 on the bottom. So the common mistake is people won't have that negative sign. If you don't have that, it's not right. You made a mistake. You didn't factor correctly, or you didn't cancel correctly. Now on the top of this fraction, we have a trinomial that will factor as two binomials. No common factors between the two, so we'll start off with t and t that makes the t squared. 7 and 3 multiply to make 21. If I make the 7 positive, 3 negative, they'll subtract to make a positive 4. Down below, we've got two numbers that multiply to make 6, but they have to be the same sign, and they have to add to make -5. So it's going to be a -3 and a -2. And so from that point, we can go ahead and take out those common factors of t minus 3 and see what's left over. So all we have there is a t plus 7 over a t minus 2. There is our answer. Well, the last one here is a multiplying problem. And so what I do when I see no addition signs, I use the commutative property. Now the commutative property allows us to move terms around, switch the order, and that's what I'm going to do here. So I have the 7 and the 5. I'm just taking all the numbers on top of the fraction, moving them next to each other. The a, the c to the fourth, and the d to the second. Notice I combined the two d's there. Down below I got a 10 and a 21. So I'm going to put the 21 here, the 10 here. Count up the a's. Well, there's no a's. Count up the b's. No b's. Well, the c's. How about those? C to the fourth power. So 1 c and 3 c's make 4 c's, and just d to the fourth. And so from that point, all we're going to do is reduce. Take out those common factors. So look at the 7. It goes into 21 3 times. That's why I didn't multiply the 7 and the 5, so I could see the factors easier. 5 goes into the 10 2 times. So we got to multiply those two numbers. These change to 1 when we cancel those out. Still have this a. All these c's are going to cancel out. 4 c's will cancel 4 c's. 2 d's, well, those will cancel. I'll take away 2 from the bottom, and I'm still left with 2 on the bottom. So what's left? Well, we've got 1a, so just an a on top of this fraction. Down below, we've got 3 times 2 makes 6, and we have d squared. So there is our simplified answer. Check out part 2 for the last 3 problems.